China is building a canal so massive, it could redefine how an entire region reaches the sea.
This is not a small waterway upgrade. This is a man-made route carved across 134 kilometers of difficult terrain.
And when it opens, it is expected to carry more cargo each year than the Panama Canal moved in its first decade.
Large cargo vessels will use this route. They carry heavy loads.
And the most astonishing part is this. Much of this route used to have no water on it at all. To understand why China is doing this, you first have to understand the hidden logistics problem behind it.
Some of China's most productive industrial provinces sit deep inland, surrounded by distance, mountains, and cost.
These are not quiet rural zones. They are powerful manufacturing regions, producing enormous volumes of goods.
Places like Sichuan, Guizhou, and Yunnan generate coal, metals, chemicals, and heavy industrial output by the ton.
Highways are overloaded, railways are stretched, and every extra kilometer adds cost, delay, and fuel burn.
For inland manufacturers, transport has acted like a hidden tax, eating directly into profit.
A factory can produce world-class steel inland, yet still struggle to compete simply because moving it to port costs too much. That gap between production and ocean access has held back entire provinces for generations.
Millions of people live in regions full of talent and resources, yet trapped behind a logistics wall.
China looked at this bottleneck and decided more roads alone were not the answer. The answer, at least in this case, was water. And to see why water makes sense, you have to go back more than 1,000 years. China once built one of the longest man-made waterways in human history, the Grand Canal. That canal did more than move goods. It connected economies, cities, and political power across the country.
For centuries, water remained the cheapest and most efficient way to move heavy cargo long distances.
A single vessel can transport the same amount as many trucks while using less energy.
So this is not nostalgia. It is ancient logic combined with modern engineering.
A new path is being forged, a modern solution to an ancient challenge.
The Pinglu Canal begins at a reservoir and runs all the way toward a river system that opens into the South China Sea.
That single connection gives inland industry a direct water route to global shipping lanes for the first time. But the land between start and finish is not easy. It is uneven, elevated, and brutally complex. And that creates a central engineering challenge. How do you transport a massive vessel over a significant height difference?
The answer is the lock, a kind of elevator built for ships.
The vessel enters a secure compartment, the gates seal behind it, and the water level begins to rise.
As the chamber fills, the vessel is raised to a higher level and continues forward.
A canal system uses 3 water control devices to move heavy cargo through changing elevations. This system is designed to be a model for efficient water use. In this region, water and land must find a balance amidst changing seasons. Some systems can be inefficient. This one is designed to minimize fluid loss.
The project features over 90 bridges crossing the waterway.
In some sections, teams are removing up to 13 million cubic meters of earth. That is enough material to fill more than 5,000 Olympic swimming pools. Efficient transportation systems are being integrated with advanced tracking platforms that monitor every movement.
Construction officially began in August 2023, with a target opening date in 2026.
With a budget of around $10 billion, this is one of the most ambitious inland waterway projects on Earth. For context, the Panama Canal took about 10 years to build. Pinglu is being pushed forward in roughly 3. The engineering alone is impressive, but the potential impact may be significant.
Moving freight by water uses roughly 1/5 of the fuel required by road transport. That means every ton shifted from land to sea brings immediate savings in cost and efficiency.
The canal is expected to handle 95 million tons of cargo every single year.
That is roughly equivalent to loading 950,000 freight train cars in 1 year.
In sheer annual capacity, this waterway is projected to outperform its historical records.
Cities along the route are already changing in anticipation of a new economic era. At the coastal end, port cities are scaling up to receive millions of tons of inland cargo.
Ports that were once secondary players could soon become critical hubs in southern China's shipping network.
Strategically, this region is part of a wider land-sea trade corridor linking inland territories to Southeast Asia and global markets.
For inland producers, this means faster and cheaper access to export routes than ever before.
There is also a resilience argument here. China's trade should not depend entirely on a few eastern megaports.
The canal creates a backup route, a second artery that reduces dependence on existing coastal bottlenecks.
But projects this large always come with human cost. Thousands of families along the route have had to relocate to make way for the canal. Roots run deep, but memories are what truly matter.
The environmental story is just as important because the canal crosses wetlands, forests, and farmland.
Engineers are building ecological corridors so animals can continue moving across the landscape.
Water quality and vegetation are being tracked in real time along the route.
Erosion control systems are designed to maintain water quality and prevent sediment from spreading into waterways. Still, large water projects can reshape groundwater, flooding patterns, and local ecosystems in ways that are hard to predict early. Experts recommend additional reservoirs and diversion infrastructure as a solution.
To achieve efficiency, all components must work together in harmony.
And that is why the Pinglu Canal matters beyond China.
For landlocked industrial regions across the world, this canal is a demonstration of what long-term infrastructure thinking can achieve.
It is 134 kilometers of engineered water, connecting factories to oceans and inland economies to the world. And when it opens, the Pinglu Canal will ask every other nation one simple question: if this can be built here, what is stopping you?